Namaste. So let's come back with the module 1 lecture 3, which is on how GIS evolved over a period of time. It is very essential in a subject for us to understand how the subject was born and how that subject has progressed over a period of time. So in today's lecture we'll understand how the subject was born, what was the idea behind bringing GIS, then once GIS was born, how it developed over a period of time, and what is the status today. We'll also look at what are different softwares that are there, what are open source softwares that you can access in wherever you are, and extremely efficient softwares that are there in today's context. So when we look at the entire concepts that will be covered today, the first one is origins of GIS and its timeline, how it started and what is today. Then I would look at definitions of GIS. So when every researcher looked at GIS in a different lens, they could see different ways of applying GIS. There are different structured methods of applying GIS. So that is where the definition of GIS comes from. Then there is the capability of GIS. So what GIS can do. So I would list out a few of them, but it's not everything, but few of the capabilities that may be useful to many of us in daily life if you are trying to apply GIS. So I would give you a list of capabilities, and some of those can be applied. Maybe during our practical class we would even cover some of those applications. And the last part is the current state of art. So what do we mean by current state of art? Did we start with something that is desktop capability, and what is till today, and how we are progressing, and what are the essentials that if you need to be a state of art technologist, so what is that thing that you need to understand is what we'll see in this set of slides. So when we think about the origins of GIS, it was with the advances in the computing, cartography and photogrammetry, which started with automated GIS in 1960s. So cartography was at its initial stages. It was picking up pace, whereas computing was really at a very advanced stage at that point of time, and photogrammetry was a point where people were understanding how it can be applied. In that case, the concept of automated GIS evolved. But it was Ian McHugh published Design with Nature in 1969, where he proposed a concept of land suitability and capability analysis. So when land suitability, that suitability of land, that is because of the geographic features, it started with the evolution of geographic information system. That was the first point when the GIS started evolving. But it was afterwards in Harvard Laboratory for Computer Graphics which developed and made available a series of automated mapping and analysis programs. So during that time it was only for mapping. So they did the automated mapping systems, mapping solutions, softwares, etc. for mapping analysis programs. So this was the first baby step in where the GIS was really progressing well. Then if we have to really say the entire package of GIS was to be built, the first GIS was born with the Canada Geographic Information System, which is also called as CGIS. So Robert Tomlinson in 1960s, rehabilitation and development of Canada's agricultural lands was his work, wherein he introduced concepts of what do you understand by geographic information system, where the geographic information was on the agricultural lands and the information was developed based on how to rehabilitate it and how to develop these agricultural lands for Canadian system. So this is where the first ideas of being a system evolved. Before this it was just a software, but now it's evolved as a system. Now once the system evolved, it was in 1970 where the very well known major players of industry started the commercial development in 1970s, that is ISRI and ArcGIS. So ISRI started producing its own cartographic products along with ArcGIS, ArcGIS is one of the excellent softwares today, which has every module of how you look at GIS. You can even write certain programs using the modules of GIS, modules of other GIS tools to produce a new GIS tool. That's how you became the software end user into this system. So to give you a brief of how the time it evolved, as I said, the first GIS was created by Tomlinson in Canada in Canada Geographic Information System. Later it was in US from the Harvard University, where they developed CMAP. So once this was done, there was a short communication wherein Jack and Laura Dagmond founded Environmental Systems Research Institute, or it's called as ISRI, in Redlands, California. So this actually paved way for commercializing GIS. So once it was done in ESRI Maryland, where Automated Geographic Information System was born in 1973. So, and in 1974 there was the first conference series which was called AutoCarto. So this was a targeted conference in order to develop the geographic information and also the spatial data, how the spatial data can interact with the geographic information. So it is the geospatial information, the conference, it was the first one. So it was more on assisted cartography, which is otherwise called as geospatial information. So with that, they did that in 1978. It was MAS, that is Map Overlay and Statistical System. This was a very effective, I would say, rather than a software, a tool in order to understand how the map overlay happens and how we can take it forward. Then ISRI in 1980, ISRI launched its first commercial software, ArcInfo, and 1996 it was MapInfo. So MapInfo is another software which it has extensive whatever you take analysis with geographic information system has good number of tools they have developed over a period of time. So ArcGIS and MapInfo are two very big players in terms of handling geographic information and the spatial data. Whatever the tool is required for any kind of research can be developed, can be also found in these systems, but also it can be developed. They have made it itself an evolving software where one can design their own tools, their own systems, their own procedures of handling this geographic data. In 1990, ESRI's ArcView, which is a platform to deliver the data to the users, was developed in 1991, and later ISRI again developed map objects. So these were small parts of the same software that was actually built for different purposes. But the revolution came in 2000, where GIS in the cloud, that was the first thinking, where GIS can also be put on the cloud, and GIS can be understood as maybe a system that can be connected elsewhere, and you don't need a system to look at a particular process or a software. It can be centralized. Such thoughts came into existence. In 2002, Quantum GIS was born. As I said, Quantum GIS is a free and open source software, and it is one of the very foremost and very good softwares in terms of handling any geographic information and spatial analysis of any data. So then you had Saga GIS. Saga GIS also is extremely good in terms of handling both any kind of data models that are available in geographic information systems. So then ISRI released an ArcGIS Explored in 2017. So this is how it started. Actually, the ArcGIS started, then you had ArcInfo, then ArcGIS started evolving. I think ArcGIS has recently even released ArcGIS 10.7. It has evolved over so many years, and ISRI took it online, wherein ArcGIS Online was born in 2012. What today's context, all these softwares in today, if you just go into some of the free and open source software list, you can find huge number of softwares available for anyone to do research without even investing a pie into the software part. I don't say that the FOSS softwares are only things that has to be used. It can be a commercial softwares. Also, FOSS softwares are quite capable of handling any type of data, given that the user has certain competence in handling the data. So what is the future? Future is GIS is now into the cloud. Every computing is going into the cloud. So centralized systems of computing has taken over the hardware resources that needs to be there. So you don't need a hardware resource, you need to only have a centralized computing systems. So that's one good thing that has over a period of years has changed, and probably the students, researchers will have more better capabilities and handling of this data can come in future with the GIS on the cloud. Then people are trying to really work on real-time GIS. So that is where the next phase of research really kicks in. The web GIS, this is a big part of today's research. So web GIS, how do you really have geographical information in the web context? What are the different standards? How do you put out the standards? Is the data interoperable? How do you save your data? How do you actually share your data? So all of these are a very, very important part in today's context, when web GIS is the one that is actually taking over the GIS as in a big way, and making it possible for every citizen of this country or across the world, across the globe, to look at the GIS data. Then looking at augmented reality. So this is the next gen thinking that the people have started inducing into the GIS system, wherein the augmented reality, the AR systems will be used in order to develop GIS data in a much better platform, so that it's much more appealing and also gives understanding of what's the depth information into it. So this is how the GIS has evolved over a period of time. So when we just put it across, first thing was cartography, automated mapping, and map algebra. That was the first step of how GIS evolved. So it was just with cartography and automated mapping everything started. Then it was with remote sensing which actually pushed GIS into also handling the raster processing capability. So we had the raster processing capability. I'll in the further classes I'll inform you what do you mean by raster, and what kind of model it is and how the model runs. Then you had computer science, the database management systems, then finally the geography and mathematical aspects in terms of spatial analysis. So clubbing all these things will make a GIS. So geographic information system is about cartography, it's about remote sensing data, it's about database management, and it's about spatial analysis. Clubbing all this would give you a single system that is nothing but geographic information system. So if someone asks you what is GIS, you have several definitions over a period of time that has been defined. The first definitions that I can think of is it is a system in capturing, storing, checking, integrating, manipulating, analyzing, and displaying data which are spatially referenced to the earth. So now when we look at this, it says spatially referenced to earth. That's why it's called a geographic data. So when there is a system which can handle this data in order to capture maybe through your scanners, through digitizers, etc., or even cameras, it captures, it stores, it may be using a database, then integrating it for various issues, manipulating the data in order to extract information, analyzing the information, and displaying the information in such a way that it is understood by various users. So it means to say that it has information, it has a system to handle it, and it is a geographic in nature. That is what it means. So other author, David Cohen, who defined it as a system of hardware, a software, and procedures designed to support capture, management, manipulation, analysis, modeling, and display of spatially referenced data. So he has put in more efforts in defining from the scratch to the end, which means to say that it has an hardware. Basically, as I said in the previous class, it has an hardware. It can be defined as a software. So along with the hardware and the software, it is a science. It is a science that helps us to capture, manage, manipulate, model and display the data. So and for solving complex planning and management problems. That is what Cohen said. Cohen had visually given the entire process of how the data analysis can be done, or spatial analysis can be done. And ISRI in 1997 defined the 5 integrative components, the key components of GIS. It said the key components of GIS are hardware, software, data, people and methods. So this was first where it started with people. Until then it was with data and information, but ISRI did define it as data with people and methods. So that is where integrating of science, tools and information started, and delivering it to the end users started to be looked at. Then there is automated systems. Clark in 1990. It was before ISRI's actually putting a subjective thought. Clark in 1990 said automated systems in order to capture, storage, retrieval, analysis and display. So this also defines the same thing, but it is on display of only the spatial data. So when we look at all of these definitions, whatever the definitions that have defined here, there are many more definitions to be looked at, but these are some of the very well known definitions. So when we look at all these definitions, it is based very specifically data, users, software, hardware and methods. So collector data and users are the last part. So data to user, you have a software, you have a hardware and a method. So that's how GIS is all about. So that is entire process of how GIS is made, can be defined as. And when we look at capabilities, so the first capability of GIS is data capture and input. Input data can be anywhere. It may be by digitizing, the scanning or direct coordinate entry. You can type in yourself, or you can scan your map sheets, you can scan your photographs, you can digitize your photographs, which means you manually on a digitizing board you create those photographs by yourself. So edit data in the GIS to correct errors or to add features. So sometimes when you are collecting certain data, you may have certain errors that may be because of there may be certain shortcomings in the field, or it may be because of some issues the data would be wrong, or it may not be as accurate as it had to be. So this can be easily corrected, these errors can be easily corrected, and you can add features. Certain features you may have noted it down, so that can be easily added into this data without much of a headache. So labeling the spatial features so that they can be identified, for example name or codes. So when we look at, let's say that I have 4 different map sets. So if I just put all the 4 different map set into my geographic system, I would not be able to understand which map set belongs to which region. So I have to then look at every map set, look at its coordinates, so where it belongs to, then again maybe locate it on the ground or on the map or on Google Earth where this actually this map belongs to. Instead, if we label it as, for example, this map belongs to Kolkata, this map belongs to Delhi, this map belongs to Mumbai, so such labeling can also be done in GIS. That's what I mean by data labeling. The next capability of GIS is to manage. This is the most important and most powerful part of how GIS works. It can, I spoke about the attribute data, so both spatial data and non-spatial data can be added as attribute data. So the querying, the linking of attribute data is extremely good in GIS. So you can have huge sets of data. For example, if you have 100 students in a class, so every student's information can be stored in the database, and whatever the query whichever teacher wants, maybe a subjective query or it may be the query about the information about a student, only a particular student, can be easily done with just with a small query, a small probably English prompt. Then link to the external databases. So you may have certain databases. You may have certain databases that the governmental agency is actually putting it forward. So you can easily link that database and match the database, retrieve information from those databases and use it for meaningful outputs. That is also extremely possible. Then make changes in the existing database. So this is very important in terms of GIS. No other map system or no other system has any capability of making any changes if there are certain errors. So such system can be done using geographic information system. So you can update database features, so which means it temporarily it can be changed, it can be updated. Maybe the feature in 1997 would have changed in 2000, 2003 it would have been changed for much better, 2010 it would have been completely different. So every updation can be done in a much easier way. Import and export from to other GIS or database managements, as I said, can be done. Combine map sheets to create larger databases. So as you understand, you have different scales in a map sheet. You have different map sheet based on scale. If you take 1:50,000, if I am looking at one particular city, maybe I need 4 or 5 or 6 maps for looking at the entire city. So if that is the case, instead of doing analysis that's only on one map and extracting information, then again doing analysis on second map, this can be combined and create a large database as large single database, wherein it can be used for multiplicity of purposes. So these are done based on the edges of the neighboring maps. So we'll also look at how we'll reference a map, how will we see how the edge of a map is there, how do we actually geographically reference without any errors. So all these things we'll also look at in the software part of this subject. And when we look at the third capability is manipulation. So manipulation in terms of different sources that are compatible so that they can draw on top of each other, which means you can have different sources, but these sources should have a common system. Okay, so common coordinate system, common projections, so that they sit on each other and all the information can be easily drained out from that system. So this can be again presented for various purposes. And when we look at the fourth component, it is about GIS capability. That is analysis. This is the most important tool that any software can provide. That is, you can select features by their attributes. For example, I have a map of entire West Bengal, let us say. So if I have to find out all the districts which have a literacy greater than 60, it means to say that I'll just give a command prompt or a query wherein I'll just say, please list out that particular row which has greater than 60%. So literacy rate anything greater than 60%. If I give a small query, the entire list is with me, because the entire database would have been populated. So I can select that feature, then create a map out of it and display it to the audience when and wherever it is required. Then select features by geographic relationships. For example, if I am in Midnapur in West Bengal, so if I have to find out all the dental clinics within the district, I just give a query with, for example, if we have dental clinics there, I'll just give a query saying that find out all the dental clinics, that particular label name in this Midnapur district. So the entire list would have been dropped down to my reference, and I can create the thematic map out of it, the map or just a map out of it. Then combined attributes or geographic queries. So when I say the first two aspects, select features by attributes or select by geographic relationship, you can even combine both of these. For example, find all the villages within 10 kilometers of health facility that have high child mortality. Okay, so such examples are can be easily done. So if you have various variables that you are trying to understand or trying to put into your model, so it is just a query of all those variables can be taken and this model can be easily built. That is where analysis comes into effect. As we see, we have already seen how we can do buffer analysis. That's one of the very important aspect of how GIS can give us a lot of information on development or issues that are concerned, or how the societal aspect has to be handled. Similarly, point-in-polygon operations, these are certain operations that I am trying to put out so that you understand how different tools are there in GIS where you can utilize it. But we will also learn many of these tools when we are looking at the practical aspect of it. Geocoding and address matching. So match all the address list on with the street map. So this also can be done with just a query. So you have your network connected, so you can always look at this. Look at network operations. Find, for example, if you have a map of your entire region, just like a Google map, if you create your own map of your district or your region and you have all amenities on it, so if someone wants to find out the shortest distance of the map, it is just a query to say that from this point to that point, what is the shortest distance that can be seen. Then the fifth capability of GIS is modeling. So for example, if someone is looking at what if scenarios, if the urban growth happens at this rate, what may be the change and where the change is in the earth's surface, on the earth's surface, where the change may happen, why the change is happening, what are the drivers that change happens. Such analysis can be done in the modeling capability. If there is an epidemic that is spreading, which province it is spreading, how it is spreading, what are the geographic locations it has been spreading into, and why. So all such issues can be just analyzed with just collection of the geographic data, maybe in a day or two, in a near real time. So such capabilities also are very important for a software of something like GIS. And very interestingly, the last part is the display and output. Here, this is where we use exploratory, where you have visual patterns and identify anomalies. For example, I have shown you here is a partial map of IIT Kharagpur. These are certain buildings in IIT Kharagpur. So these are most of them are academic buildings. So when we look at this, we can do analysis such as, if I have a buffer of so many meters, so and we have a green lawn, so what kind of area that is required around these buildings, or what are the facilities that can be put in around the building so that the students have an access to such issues. If you put it in 5-meter buffer, 10-meter buffer, if I put it in 30-meter buffer, or if I put it in 500-meter buffer, so how many departments are going to be engaged into such issues. So all of these things can be easily analyzed just with having certain data that can be built in. So any kind of analysis, and anyone needs a specific analysis, can be easily done with such data. Produce very high quality map outputs for publications, and also create a digital or paper census at last. So this is what is actually taking up today's word. So a digital paper or digital paper census at last, which is extremely good. Export map output to other packages. So interoperability of any of those is very is an inbuilt package in any GIS software. So that can be done. So GIS can be used in planning and policy analysis. For example, when I say I started with the real world, how did we collect data, what are the different sources, this I will speak in the next class. Then we look at data management. Once we look at the data management, how we analyze the data, and finally it is users who get the information for decision making. It can be any governmental users, it can be any private users, it can be any normal user who actually look at the data as information for any decision making, any of the other aspects that is required. So when I say current state of art, there is two things. One is if you want to have a very high-end state of art. So when I say high-end, you have integration of GIS, you have integration of remote sensing, and added to it is you have machine learning, you have various other aspects that is built in, which can actually come in handy when you are looking at certain modules or modular things that needs to be built in as a models. So when we are looking at interoperability, OpenGIS standards is one that people are looking at, and interoperability of any of your layers and interoperability of the capability of your software is one that is looked at. Then advanced spatial analysis, can it be an GIS system can do an advanced spatial analysis? It's not just querying, but can it do an advanced spatial analysis? Now also is one of those what we think about. Scientific visualization, then storing spatial data in database management system. So and also a perfect database management system, that is what is called as a high end. And when we look at low end, it is desktop mapping, any of those commercial data providers where you where many of those data providers don't allow you to actually rephrase or look at your data, map your data in a different way, it won't be allowed. So that such things are considered to be a low end. And you have maybe mapping add-on on spreadsheets, global positioning system, digital map libraries, so access to spatial data via internet. So these are all considered to be a secondary sources. So it's kind of a low end. But when you look at today, it is all about mobile. So with smartphone, everyone is a potential data sensor. So this volunteer geographic information can be from any individual. Collect data, collect a crowdsourced data. Simple things that daily social media updates is a gateway of location associated information, geographic information. If I am saying that I am holidaying here, so someone is traveling from here to there, someone is traveling from here to here, these are location based informations. So such information are extremely very important when we are looking at it. So then we have contents on mobile. Social media becomes a part of crowdsourcing efforts, data analysis on site. For example, when you are looking at asset management, field data collection, inspection, incident reporting, so all of these are the things that is happening with mobiles, and real-time GIS and mobile GIS. So this together will put into one distributed system architecture which is very effective. So and finally the last one is the web platform, which has taken over the entire GIS system by a revolution. So it consists of a server and a client. Client is normally a desktop browser, and the GIS server is inbuilt somewhere, maybe in remotely. So what is the advantage of this is global reach. Anyone, you develop data sets, you develop data, so anyone who wants to access the data need not go back, revisit the same place and access the data, whereas this data can be easily accessed by them for their analysis. It also helps in diverse application. Your application can be one, but there will be 100, 200, 300 more users who may use the same data in different applications. So it will reduce cost to a very large extent, and you don't need any installation of software. So web GIS is extremely efficient. Then you have better cross platform capability, that is you can use it on any platform. So like your software, whether it has to be installed in Linux or in Windows, so it doesn't have any platform, it's just a browser. So any browser that is capable of handling opening that website and having certain plugins, so you can use this web platform. Easy to use and compatible with different browsers, and customized dashboards, and what else. So such things are the state of art that is there today. So to summarize today's class, we looked at origins of GIS and timeline. GIS is evolving a very strong subjective tool to all fields, and GIS is, as I said, is a telescope, is a printer, is a scanner, is a mapper, and what else. So GIS capabilities, you have data input, management, manipulations, analysis, modeling, and display output. So it's from the starting of the data input in order to produce the entire information. That's how the capability of GIS is designed. And we also looked at current state of art platforms, and we looked at how mobile platform and the web platform are taking GIS by revolutions. So there are extremely good platforms. For example, Bhuvan is one such platform. If you guys get some time, please look at Bhuvan. Bhuvan is extremely good platform in delivering data to users. Thank you very much. We'll meet in the next class. We'll look at many more aspects of GIS. Thank you.